Okay, hello and welcome. This is lesson 7.4, one of the last two lessons in our chapter 7 through algebra, the Holt-McDougall curriculum. And in this lesson, we're going to be talking all about exponential growth functions. Why does that say exponential graph functions? That should say exponential growth functions. And what we're going to be doing here specifically, we're going to talk about the differences between a linear function and an exponential function. We're going to be able to plot points to graph an exponential function. And then we're going to look at an exponential growth word problem. So let's go ahead and jump right in. So is it linear or is it exponential? In section 7.1 of this chapter, the previous video, we talked a little bit about the difference between repeated addition versus repeated multiplication. And repeated addition is multiplication. And repeated multiplication is an exponent or powers. So we did this to sort of talk about the points of how we multiply together variables and how that affects the exponent rules. Now what I'd like to point out to make sure that we see this, right, is that way back in the day when we were talking about linear functions, what we had was repeated addition. If you were to take a table of values, and just to throw a couple down here, and we had this type of setup, we can see that on the left hand side our x values, we are increasing by 1 every time. This is a constant amount that's going up. And on the right hand side we are always adding 2. And what that means is, or what that meant was, that this expression right here, this table, can be expressed as an equation. So we have our y value. This value can be determined by taking the x value. And because we're repeatedly adding 2, I know that instead of adding 2 over and over and over again, I can take 2 and multiply it by x, because repeated addition is multiplication, to find out just how many 2's we have added on. And then to find the y-intercept, I just go back and I find out where x is 0. In this case, it would be 3. When x is 0, it's 3, because going backwards in the pattern, I subtract 2. And so I would end up with this equation. And we called this the slope, and we called this the y-intercept. And we had this slope-intercept form equation, right? Y equals mx plus b, right? This is for linear equations. And I know that this equation is linear because I am repeatedly adding 2. Repeatedly adding something makes a linear equation because it's going up by the same amount through addition every time. And again, that's why this slope is a multiplication problem, because repeated addition is multiplication. An exponential function, on the other hand, is the exact same logic, but instead of repeated addition, we have repeated multiplication. So I'm going to take these, the same idea, and I'm going to multiply by a number. So I'm going to start at 3, and then we're going to multiply by 2. So that's 6, 12, 24, 48. So over here, I'm going up by 1 every time. But on the right-hand side, instead of adding every time, what I'm doing is multiplying by 2 every time. Multiplying by 2 every time. Almost wrote an addition sign. And this tells me that, first of all, this is an exponential function, because repeated multiplication makes for an exponential function. But how do I represent this as a function? Well, it's really very similar to what we did over here. The y value is equal to how many times, over here we said how many times was 2 added to itself. Well, over here we're going to say how many times was 2 multiplied by itself. So I know that when I'm talking about repeated multiplication, it gets represented as an exponent. So instead of 2 times x, because we're repeatedly adding, we have 2 to the x power, because we're repeatedly multiplying. And along with that, we have to have our starting point. In this case, our starting point is 3. So if I start with 3, and then I multiply by 2 over and over and over again, I get this function. And so this function represents that table. And in general, we end up with y equals a times bx, where a is our starting point, and b is our growth rate. In this case, our growth rate was that we are doubling every single time, so we continuously multiplied by 2, and I started at 3, so I put the 3 right there. 3 times 2 to the x. So let's do another quick example. Actually, no, I'm sorry. These were your examples. If you want to go back to your Canvas lesson now, I have a few situations where I want you to just tell me, is it linear or exponential? So go ahead and stop the video now and check out your problem.